So today I did a lot of refactoring with the code. It's not a whole lot of code, so it wasn't that complicated, but I wanted to make it more structured and modular and try to reuse some stuff. So I think what I'm actually going to do is I'm going to start over in my utils file, and you'll notice over here I cleaned up some of these files that I had the splitting and parsing functionality for, and just put everything in a http underscore utils file. So you'll notice we still have this HTTP request class, which inherits from the enum base class. So that way we can do some type checking and type safety with the 9 defined HTTP request methods. You see, I added on 2 more classes here. And before I talk about these 2 classes, let me actually first talk about this function here. So I did the underscore to make it a private function so that unless you explicitly import it, it's not going to be in the namespace of this script when you import it, which I believe that's how it works. And honestly, let me just validate it to make sure. So let's do import. Let's close this out or comment this out. And now we should be able to do okay, so it is. Oh, I know. I think I know what this is for. It's it's for wildcard imports. So if I do from http underscore utils import star, then that means that this method should not be in the namespace. So I should be able to see stuff like split on CRLF. See, that loads, but then this should not load. Okay, yeah, see, it's not being recognized. So, yeah, I basically did this first underscore here because it's a private method that I'm only using in this HTTP underscore request lines constructor function. And so if you didn't know, I'll just quickly explain this. Uh, if you prefix a method name, and I think also class names with an underscore, they don't get included in the namespace when you do wildcard imports. And a wildcard import is like this from HTTP utils import star. So when you're importing star, that's a wildcard import. People don't do this very often, so this isn't that helpful, but the underscore oftentimes is just used to indicate to whoever's reading the code base that this is a private method. So that's why I did that. Anyway, I just got distracted by that, so let me go back to what I was actually talking about. So this was the code that I had from a previous video where I was identifying the request type. And what I'm doing is I'm taking in the bytes and I'm returning one of these HTTP request objects from this enum class. So what I start by doing is taking in the request bytes, and I use the find method to find the first instance of a blank space. And then after that, I take everything up to that blank space. So if you think it's get space HTTP convention or post space HTTP convention, etc., if we take everything to the left of that space, that's going to be the name of the type of request that we're making. And so to verify that what we got was actually a valid HTTP request, we try to retrieve it from this enum class. And if it's not a valid, or I guess if this string that we're getting back from the decode method is not a valid field in this enum class, we're going to get a value error, which is why I've got this try and accept block here. But if it is a valid field, then you're going to get a HTTP request object. And that's what we'll use to identify the type of request going forward. Additionally, I talked about taking those 2 split on CRLF functions and putting them into one. Originally, I had one to split on double carriage return line feed like this, and on single, what I did is I just included a Boolean flag called double, where if we want to split on 2 carriage return line feeds, we pass that explicitly, but otherwise it defaults to false. And so I wrapped all of that in the same function. Let me talk about these 2 new classes first. So the first one is the HTTP request line. It's got 2 attributes. So we've got the method, which we get by calling that private function I just talked about, and then we get the line bytes. So we store just the raw bytes and also the method that we parsed out of it. Additionally, I've got this HTTP headers class, and I recognize that what I'm doing here by decoding to a string is probably not optimal, and I could do some splitting logic just on the raw bytes by finding the encoding for this character. Um, but I will do that later. Honestly, I was pretty tired tonight, and so I knew this way would work, and I will try to think of a more optimal way where I'm interacting with the raw bytes rather than this string tomorrow. But let me just explain the logic. So I'm creating a dictionary of HTTP headers because if you notice, every HTTP request that we send, the headers are of the form like key values, where the key and the value are delineated by a colon. So what we can do is we can go line by line, look at all of the individual bytes which represent lines, which are returned by our split on carriage return line feed function, and we can split them, or first we can decode them to a string with this line, and then we can use the split function on that string to split between the key and the value portions of this line, which we're representing as a string. Excuse me. And so you'll notice that I use this max split keyword argument inside the split function. What that means is that we're only going to split this string on the first instance of a colon. So for example, if we've got like the host HTTP header and it's like host localhost colon port 8080, there's actually two colons in there. And so if we apply just the regular split function, that would mess up and return three fields, I believe, when we only want two. And so that's what this max split flag does here. So what we're doing is we're going line by line, encoding it as a string, splitting on the first colon, taking everything on the left as the key, everything on the right as the value, and then updating our dictionary with the dictionary.update method with that key value pair. I hope that makes sense. Let me run the main script so you guys can see what I mean. So let me pull up my terminal real quick, and let's start the server. Or actually, let's talk about the code first before I start it. So I'm importing those two classes and the split on carriage return line feed function from HTTP utils. Additionally, here's how we're doing it. We're taking in the raw data from whatever client is connecting to our TCP server. We're splitting first between the requests and the body by using the double flag, double equals true flag on split on carriage return line feed. So this is the request line and all of the header lines. This is the body. Down here, what we're doing is we're splitting the request line and header line on single carriage return line feeds by calling that same function with the double flag equal to false. And actually, we can get rid of that explicit keyword argument because I set the default value of that flag to be equal to false. Next, we're going to create those two classes that I made here. So the HTTP request line class and the HTTP headers class. So by calling the constructors of both of these functions, we get that back. So here we're taking just the first line from the request and headers list of byte lines, and then here we're taking everything after that because that's the structure of how it goes. Is you have your first line is the request line, then everything else after that is going to be HTTP headers until you run into the body. So we're going to print the method that we got back from creating this object, and we're going to print just the raw line bytes that are associated with the request line object. And then here what I'm doing is I'm pretty printing the HTTP headers dictionary from the HTTP headers object. So remember, we're creating a dictionary where each key and value is a line from the HTTP headers in the raw bytes which were sent to our server. And so the way I'm going to display it is by pretty printing this dictionary. And for whatever reason, pretty print automatically sorts dictionaries by their keys, which I don't like that. I always set that to false. I guess that's part of the idea of pretty printing is that you're in alphabetical order, but I always find that annoying and I almost never want to sort by the keys alphabetically. So I'm setting that to false. Regardless though, let me pull up git bash and we can get started. I can show you how this works. So start up the server first, pulling up git bash. Let's start with just a default git request from curl. So you can do localhost port 8080. Send that. So here we can see this is the first print statement. The method is a get method. That's correct. This is the raw request line. So we got get slash with 1.1 HTTP version. That's correct. And now here we can see this is our dictionary that we got back for all of the HTTP headers. So we got the host, which is localhost on port 8080. That's right. We got the user agent, which is curl this version. We got accept */*. Awesome. Now let's see what happens if we do a put request. So I'll do curl x put HTTP / localhost 8080, and I'll keep using the same example that I did before of just a basic JSON object where it's the name as the key and my name as the value. So let's see right here. This is the second one. So we've got put is our request type. That's correct. This is the line for the request. And then here is our dictionary of HTTP headers. So we've got the host, localhost, port 8080, user agent. We've got this. We've got the content length, which is 16. And then we've got the content type, which is application XWW for URL encoded. If I wanted to, I could specify the application type. Not sure why. That's weird. Okay, I guess when you do the slash here for a multi-line terminal thing, if you go back up in the terminal history, that goes away. Let's do. I'm actually not sure how to specify the content type. I'm not sure what flag that is, but you get the idea of what I'm trying to do here. And we're not printing the actual data or like the body, so we can print the body after that by printing the result that's returned by our first invocation of the split on carriage return line feed function. So basically, you guys can see what I'm going for here. So I've got code that determines the method, determines all of the flags, and determines the body. So with all of those things separated and put in their own classes, it's going to be pretty easy to figure out how to go line by line and address each response according to the type of information that was sent in the headers and the type of information that was potentially sent in the body. Uh, I honestly would have liked to have gotten more done today, but I decided I wanted to make a TikTok video where I just explained some basic math concepts. I've got a friend who's been doing TikTok and he's been having some good success with it, so it inspired me to try to make some videos and see what goes on with that. So apologies for not getting as much work done on this as I could, but I'm gonna hit it hard tomorrow, and honestly, I would like to see if I could finish it tomorrow. But yeah, with all that said, this is just a quick update video. Uh, this is where I'm at right now, and I think we're getting to the final part of getting ready to send back HTTP responses.